Hi there, it's Mr. Mitchell here from Malmesbury Science, and today we'll be looking at the second of two videos measuring a rate of a chemical reaction. I'm going to show you two methods to measure the rate of a chemical reaction today. Firstly, using a measuring cylinder, and secondly, a gas syringe. For the reaction today, I'm going to be using magnesium and hydrochloric acid. I'm going to be comparing two different concentrations of hydrochloric acid. I'm going to be looking at 2 moles per decimeter cubed against 1 mole per decimeter cubed. 2 mole per decimeter cubed means for every decimeter cubed of water I have, every litre of water, I am dissolving 2 moles of hydrochloric acid in the solution. I'm going to start by measuring 50 centimetres cubed of 2 mole per decimeter cubed hydrochloric acid in a measuring cylinder. I'm going to pour the first 45, making sure I read at eye level to see the bottom of the meniscus. As I get close, I'm going to use a pipette to add the final few drops. I'm going to pour the hydrochloric acid into a conical flask with a bung and delivery tube. The first method I'm going to show you is a measuring cylinder filled with water and inverted that the gas will displace as it's produced. Push the measuring cylinder into the trough and then slowly lower the top of the measuring cylinder down to fill it with water. This will eliminate the risk of getting any air bubbles in the measuring cylinder. You then need to clamp the measuring cylinder in place about 1 centimetre off the bottom of the trough. Make sure that you can see the scale on the measuring cylinder because you're going to need to record the gas being produced every 10 seconds. Put the delivery tube into the bottom of the measuring cylinder, like so. You're going to add the magnesium to the conical flask, and as you do this, your partner's going to start the stop clock. At the same time, you're going to have to put the bung immediately onto the top of the conical flask, making sure there's no room for the gas to escape. As the gas is produced, water is forced out of the measuring cylinder, and you need to count how much gas has been produced every 10 seconds and record it in your results table. This time I'm using the 1 molar hydrochloric acid to see if the reaction's a little bit slower. I'm going to once again pour the hydrochloric acid into the conical flask. And as you add the magnesium, insert the bung and start the timer at the same time. Once again, we're measuring the gas produced every 10 seconds. An alternative method is to use a gas syringe. We're still using a conical flask, bung and delivery tube with the hydrochloric acid and magnesium. However, you're measuring how much gas fills up the gas syringe. Once again, measuring the amount of gas produced every 10 seconds. The gas syringe needs to be kept dry at all times. Otherwise, there's a risk of the plunger getting stuck and you won't be able to get any results. Now you've collected results of different concentrations, you're going to draw a graph of your results. On your graph, you'll have time along the x-axis in seconds and volume of gas collected every 10 seconds in centimetres cubed on the y-axis. As you can see, the 2 molar hydrochloric acid has a much steeper curve than the 1 molar hydrochloric acid, therefore has a faster rate of reaction. The results reach the same point. That's because we used an excess of hydrochloric acid for this reaction. That means that the magnesium is the limiting reactant. The reaction will stop when all of the magnesium has reacted, and so that means there's only a certain volume of gas that can be produced. There are some sources of error to be aware of in this reaction. Firstly, the fact that we are starting the timer, putting the bung in the conical flask and adding the magnesium all at the same time is impossible. This means it's a good idea to have you and a partner doing this reaction, as it would be very difficult on your own. Also, some hydrogen may be lost at the start of the reaction. Another source of error is that the measuring cylinder is quite imprecise because we can only read every 1 centimetre cubed of gas that's collected. If we were to use an inverted burette, this would be much more precise, as we can see every 0.1 centimetre cubed of gas collected, and therefore have a greater degree of precision in our results.